Baby supermassive black holes traced by NASA Telescope 71. In January 2022, the James Webb Space Telescope, JWST, arrived at its designated spot in space. Since then, the $10 billion observatory has ushered in a new era of astronomical observations. In its maiden year of service, Webb stumbled upon faint little red dots in the distant universe. These red dots are not just specks in space, as per the Institute of Science and Technology Austria, ISTA, researchers. They thoroughly examined faint red dots and found that these were miniature versions of the supermassive black holes. Without having been developed for this specific purpose, the JWST helped us determine that faint little red dots found very far away in the universe's distant past are small versions of extremely massive black holes. These special objects could change the way we think about the genesis of black holes, assistant professor at ISTA and lead author of the study. The discoveries might shed light on various properties of supermassive black holes, particularly how they became behemoths in the early universe. The present findings could bring us one step closer to answering one of the greatest dilemmas in astronomy. According to the current models, some supermassive black holes in the early universe have simply grown too fast. Then how did they form? Identification of black holes. The Hubble Space Telescope initially caught the cosmic objects, which seemed to be a regular galaxy. After the arrival of JWST, the telescope was used to determine the population of objects by focusing on a small region of the sky. A careful review of the Deep Field Webb images revealed that the objects are supermassive black holes. However, they are not overly massive ones. As per the press release, identifying H-alpha spectral emission lines confirmed that the objects are small-scale supermassive black holes. H-alpha lines are produced when hydrogen atoms are heated. The wider the base of the H-alpha lines, the higher the gas velocity. Thus, these spectra tell us that we are looking at a very small gas cloud that moves extremely rapidly and orbits something very massive like an SMBH, said Matthew. However, the little red dots are like baby quasars, mainly luminous galactic cores powered by supermassive black holes, SMBHs. The black holes lurk at the center of the galaxies, and researchers usually determine its presence through the quasars. Moreover, the researchers state that the identified baby quasars are the precursor to cosmic giants. Problematic quasars. While the problematic quasars are blue, extremely bright, and reach billions of times the mass of the Sun, the little red dots are more like baby quasars. Their masses lie between 10 and 100 million solar masses. Also, they appear red because they are dusty. The dust obscures the black holes and reddens the colors, Matthew explained. As gas escapes from these black holes, it punctures their dusty cocoons, transforming them into the giants that puzzle scientists, the troublesome quasars. Studying baby versions of the overly massive SMBHs in more detail will allow us to better understand how problematic quasars come to exist. The baby quasars were found through the JWST-based datasets called the IGER, Emission Line Galaxies and Intergalactic Gas in the Epoch of Reionization, and FRESCO, First Reionization Epoch Spectroscopically Complete Observations.